we'll start recording. So let's try to write a little program here. Actually, I might even have it. Look, animal. Yeah. Should we just delete it and do it from scratch? Ah. And I apparently can't type at all today. It's Alex's keyboard here. Right.
Therefore, it's my fault.
Yes. So I'm going to make a class here, and I'm going to make it abstract. We still have to put the word class in, right? Abstract class animal. And remember, when the class is declared abstract, or if it's an interface, then you cannot instantiate the class. And it sort of makes sense, because if I told you to go and find me an animal out in the world that isn't a specific animal, then I don't think you'd be able to do so, because what is an animal that isn't a specific animal? If you came with a fish, I'd be like, well, no, that's not an animal, that's a fish. Although, yeah, it is an animal, but it's more specifically also a fish, or a fox, or whatever, right? So it makes sense that that nowhere in the world are non-abstract animals ever hatched or born anywhere. You all taken biology 101 or whatever it is. Some of you took geology because you couldn't handle the squishiness. But what we can do is we can say something like, should we make a private int legs? So we do that, and then we can say public int how many legs. And since all animals have 0 or more legs, then that is a reasonable feature to have in this class. And of course, because it's an abstract class, it doesn't mean I can't put any sort of code or state in there. So we'll do this. And then we also want to know what one of these things say. So public abstract say, are we supposed to, well, we'll have it return a string. But what does an animal say in general? I don't know. So the generic animal here, animal, doesn't have a sound, right? Animal is not a terminal. I don't know what that means. I guess we'll find out. So I'm just saying, hey, if you want to, if you ever want to instantiate a subclassed animal, then you have to implement this. Oops. It has to be public abstract string say. There we go. I don't know why the colors look. There we go. So now we can we get to the controversial part about, you know, what do animals actually say? Alex and I have had many discussions about this. So we'll put a class in, and we'll do maybe I don't know if we can agree on what dogs say. So a dog extends animal. Vo, not Val. He's not German. It's a Danish dog. So we need a constructor for a dog, and in some way, you know, we can do this in a number of different ways. We can say we'll make one here, and we'll take in the number of legs, right? And if I do that, then since the number of legs is a private that's set in the superclass, then the best way to do to get that set is to have a constructor up here that takes care of that. So let's give this a public constructor. So public animal int legs. This dot legs, that's the field, equals legs, that's the parameter. Now, just because it's abstract again doesn't mean I can't put a constructor into it, because eventually it will be constructed, right? So all I got to do here is now say super legs, because that just passes the value of legs passed to the constructor of the dog to the animal constructor. And that's it for that. And then we got a public string say and return whatever a dog says. And it says vote, of course. Right? Right, so let's do another one. Class emu. Start looking up what an emu says. I just actually saw a video about a screaming emu earlier today, and it's sort of a weird sound. Right, so we need much of the same. Public emu int legs. Actually, what we could have done, and I'll just show you that in a second here, because we are. It is possible to have a three-legged dog, right? If you have a specific dog, I suppose. But as an animal class in general, I suppose dogs have 4 legs and emus have 2. So nothing stops me from actually creating. Oops, where this guy needs to extend animal. So nothing stops me from making 7-legged dogs, right? So alternatively, what we could do here is we can just say the constructor for the emu takes in no arguments, but it calls the super constructor with the value 2 because emus have 2 legs. So I don't know which one you like better. Here we force a certain number of legs on an animal, and in the dog situation we allowed the user to. I thought Australia's public enemy was the cane toad. I don't think I'm
There's
wrong.
A lot of
I don't actually think I'm wrong about that.
Really?
Yeah.
It's a toad problem.
Yeah, they've got huge toad. They're big. They're like
Oh,
dinner plate
yeah.
bigs. Like, you know,
menacing things.
you can't even eat them. Right. So public string. Oh, it was a small say, wasn't it? All right, Ben, you're on. What do emus say?
They say dum dum dum.
Oh, really?
It literally sounds like a drum.
Dum dum dum. Yes, it does sound like a drum. That's exactly it. So I guess
That is so
we'll get an emu to
expected
deliver the bad news when people fail. Now I can't help but do this one here, right? And again, we can just do that as a super 4 because foxes have 4. Public string say. What does the fox say? I don't know if I can spell that.
Well, no, it's like, what do you say?
Oh, I say a lot of things.
Neener,
Neener, neener. All right, so that thing from Ylvis.
What does an owl say? Hoot hoot.
Hoot hoot. No, they go oh, oh. I think, but I don't know how to spell that. Anyways, should we just compile this and see if it actually is even close to working? Ah, look at that. So good. All right, let's put a main procedure in here. So we'll say, actually I won't make it public. I'll just say class main. Public static void. Public static void main string args. And I don't know, we'll say fox f equals new fox, dog d equals new dog. So actually, I'm just going to go change something up here in the dog because we could have one to create 3-legged dogs, but we could have a standard or default constructor that just always create 4-legged dogs, right? So if I have that, then I can just instantiate that without giving it number of legs as well. And new emu, right? So now if I say system.out.println dog d.say Control A K Y Y Y, and then I suppose we need an F and we need an E, and then we need 2 closing brackets like that. All right, so Java main. so it's exactly as we expected, right? And then there's really nothing interesting. Well, I don't know if it's interesting or not interesting, but this is sort of the stuff you learn in 202, I suppose. Now, what if I wanted a zoo? So it's going to be a small zoo because it's only going to be 3 animals. But a zoo with just one kind of animal is not a zoo. That's a farm. And I don't want that. So I want one of each of these things. And I'd like to have a structure that I can keep my zoo in. So, for example, an array. And I can't make an array of emus because I have a dog and a fox. I can't make a dog array or a fox array because I have an emu and one of the other things. However, I can make an animal array because foxes, dogs, and emus are all animals. So if I do this, I can say new don't be confused here because I'm not creating a new animal array. Sorry, I'm not creating a new animal. I'm creating an array that holds references to animals or their subclasses, right? And I'm just going to put F, D, and E in here because we already have them. So now I should be able to say something like I was programming PHP yesterday, so I want to put dollars everywhere. For int I equals 0, I less than 3, I plus plus. We could have said, we actually could say zoo.length, and I can never remember if it's length or if it's length. Guess we'll find out. System.out.println, and we need an animal in the zoo at position I, and I want to call say on it with the appropriate number of brackets, I guess. So there we go. It worked, and look at that. So what we have learned here, we can actually we can explicitly show by taking an animal A. So that is a reference to an animal object or one of its subclasses because I can't instantiate an animal. If I tried to say new animal, that wouldn't work. But I can certainly say A equals D. I can say A equals F. And I can say A equals E. And what happens if I say system.out.println A.say? Well, I'm calling say an A, and that's abstract. It doesn't have a body, so I wonder if that'll compile. Let's see. Well, it does. So what happens when I run it? Well, we get an emu sound at the bottom because the last thing I put into A was exactly the emu. I'll post this, if I remember, I'll post this code up on Yap. So you should have seen something. You should have seen something like this before. Now let me go to here, and then if I could actually find my there it is. I don't know what color I should write this in. Some fancy color. I should do that in pink. Right, so this is just an aside about Java in general. And it reads as follows. A variable of superclass, and here you can think of the animal. So a variable of animal class can hold a reference to an object of subclass. Oops. There we go. Now, this seems to be so the string function say in each child class overrides the parent. Yes, it does. And let me come back to something in just a second. Just remind me if I forget. So I just want to explain to you so you understand fully why it is that it's this way around, because this one sort of seems contrary to what would make sense, because superclasses. So if I have we can just do a small example here. So here is class A, and these red things are fields of A, right? So let's say that that's the state that can be inside an A. All right. Now, if I make a B class that extends A, then, oops. We can do something like this. Class B extends A, and maybe we'll give B some fields as well. Okay, so let's try the following. We can say A equals new A equals new B equals new A, and B equals new B. Now, it's pretty obvious that an A can hold a reference to an A, and it's pretty obvious that a B can hold a reference to a B. Nobody is in doubt about this. The two middle ones are the ones in question. And it seems like this guy here ought to be correct, because if I look at it, look, the B square, or the B thing here, is much bigger than the A, so surely a B can hold an A. Well, we're not talking about volume here. We're talking about access to properties. If this were true, then through this B reference, so actually let's write this down. So for this one here, if true, then surely this stuff is accessible through little b. But that doesn't make any sense, right? Because I've just said little b is an A. So that means what I did, I constructed an object based on this class. No mentioning of this stuff at all, right? So if this green stuff, which will be the fields of B, are accessible when I create an A, but A knows nothing about B, B knows something about A, then there's a whole lot of stuff here that doesn't make any sense, right? So you certainly can't do that, because if you could, you are now all of a sudden accessing stuff that hasn't been initialized. So no go here. Now what about this one here? Only the red stuff is accessible. So when I look at this here, it says, right, I have an A, that's this guy here, it has red stuff. But even if I put a B in, since a B also has red stuff because it inherits that from A, I can still access the red stuff of this, but I can't get to the green stuff. However, for this guy here, so we'll give that one a green check mark. It is worth noting that to get to the green stuff, we can just cast it, right? We can just say, so we can just take our, what do we call the variable, A, and then we'll tell the compiler from now on it's really a B, and now you can get to the green stuff, right? Now, unfortunately, this cast here is runtime checked. It can't be checked at compile time because you can tell the compiler anything. There's no way the compiler can check whether this is true or not. The only thing the compiler can do is to say, all right, what type is A? Well, A is declared to be an A. What about B? Is A and B in the same hierarchy? Yes, because A is a superclass of B. So it could be plausible that you're casting something of type A to something of type B. But we'll check at runtime that whatever is in this A guy is really a B when we get there, because there's no way we can do that at compile time. So this stuff you really should have been drilled on and gotten into your, because this is sort of the foundations of object-oriented programming, right? So let's just see. So Alex asks, so the string function, say in each child class, overrides the parent class. That's why you're able to do that, right? So if I go back to this example here, and we just take a look at what I did. So because the way I implemented the animal, I made it abstract. I could have made the class of animal not abstract, and then you would have been able to instantiate it, right? We could do the following. Class, how do you spell Chihuahua? Chiua. IUA. Undrata. Extends dog, right? And I suppose, could somebody check how to spell Chihuahua?
It's the way Joey spelled it.
Oh, sorry, I just need some more H's in there. C-H-I, that's an awful lot of H's. Are you sure about that?
You can
Yes.
just write it rat dog.
C-H-I-H-U-A. Yeah, that's what I said. Unrata. That's why we need to change that. So, you know what? I cannot. Let's see. C-H-I-H-U-A. And I suppose they have mostly 4 legs as well. So we'll just say super 4. I don't know if they're super, they're small. Public string say. Suppose they say yeah, or something like that. Now let's go down here again now, and let's say for the sake of an argument that we put a Chihuahua in here. As well. So what's going to happen now in terms of say, right? So, well, hopefully we should get. Can I just comment this part here out so we don't get all confused about what it is we see on the output? Look, it yapped. It didn't vote like a real dog. Yeah, I cannot roll it. You can't roll an 8. Come on now. You know. Chihuahua. Go get Ben. He's our local resident.
You should be listening.
Oh. Yeah, but
Yeah,
his Spanish is sort of crappy.
Well,
He says you're letting Spanish-speaking people down.
Oh. For not being able to spell Chihuahua. Can you? Why didn't I pick a Yorkie? Yeah, that's true. My cousin has one of those. It's sort of a not very intelligent mop. You know. No, what we should have done is we should have picked a Chow Chow, because those are smart animals. Actually,
Sure.
no, they're not. They're kind of dumb,
Sure.
but they're awfully cute. I can roll my R's. So that's not a problem. So what happens if I do the following? Well, actually, I want an animal A, and I want a dog. I actually have a dog D, so we can just reuse that one. So if I say A equals new, it would have been better if I put that in a different variable, but that's okay. So if I do that and I say system.out.println a.say, then we know that what we get is a yap, right? You don't speak Portuguese, Ben, because Portuguese people yell. I had a Portuguese or a Brazilian roommate for years. He never spoke. He yelled. So you're way too calm for that. If I do a dog, if I say D equals, we can just use the instance that we have in A like that, and then we'll go up and do this. Then do I get a vowel or do I get a yap? Well, we probably get a yap, right? Because that would be consistent with. Oh no, I can't do this. I gotta turn this. Actually, so what's the problem here? Well, it says, hey, you're trying to take something of type animal and put into a dog. That's the stuff we just agreed that you couldn't do, right? So I can do that, right? I can cast it to a Chihuahua, or, you know, I can cast it to a dog. Let's try that, because now I'm casting it to a dog. I'm saying you are a dog. So do I get a yap or do I get a vote at the end? You get a yap, right? It's yap, yap, yap. It's actually Chihuahua all over the place now. So really what happens is, and I think we can, if we look at this, if you look at line 144, so the third, I don't have a mouse that I can use here, so I don't think I do. No, I don't. Oh yeah, I do. Here. So you can see here it says, this is actually an invocation of animal method say that returns a string. It uses this thing called invoke virtual, and in invoke virtual, that means it's invoking the function as a virtual function. And are you all totally up to speed on what virtual functions are? And I have a feeling that people probably just say, no, I forgot, or the 202 teacher didn't tell me, or whatever. In general, a virtual function works in such a way that when I generate the code, you see this code says animal.say because it's invoked on something that is of type that's declared to be of type animal. But when we have a virtual function, then we disregard what the compiler generated and we look at the reference. That reference is actually the reference that is right here, this stored in register in location 5. We look at it and say, hey, I know you're an animal, but what else are you? And then it comes back and says, well, I'm really a Chihuahua. And then the runtime system will say, fine, we'll call say in what you really are in the Chihuahua class rather than in the animal class. And that's really all there is to that. Virtual functions are no more complicated than that. So right before we lose this up the window here, let's see what was the thing about except in C++. Yeah, but that's not a real language. So back to your example, you should be able to instantiate a new animal to equal a new fox, and then without casting, attempting to, yeah, that's exactly what we saw here, and that will not call a compilation error, of course, because that a.say, if animal A equals new fox, compiler will look at it and say, hey, I know for a fact that A is not an actual animal instance because you can't instantiate it. So if it has a value, if it's not null, then it has a value of something that can be instantiated. Otherwise, you wouldn't have instantiated it. Which means that I can call say on it, and it's going to be a virtual function, so it will have an actual implementation. So it certainly will not cause an error. It will just cause one of these invoke virtual things. Right. So enough about that. Unless there are some other questions, because we need to talk about first sets. Right, so back to first sets. And let's just write down the rules again. So we can say that if A is in sigma, just a terminal, then first of A. i.e. the set of terminals that any string derived from A can start with. Well, all the strings that can be derived from A start with, well, they are all A, so this is just a single A. That's not the hard one. The next one is an epsilon. So what do all strings that are empty start with? Nothing. So that's just that. This is really table 4.1. I'm just going to add something to this. I'm actually going to add a 2.5 rule, I think we'll call it. So if I have x goes to y1 or y2 or ... or yn, then the first of x is just the union of I1 to n of first of yi. That's the one we did last time as well. And then here's the more complicated one, which we just finished off last time, and that was when I had a right-hand side that could be sort of anything, right? Note up here, those are a number of different right-hand sides. This is just one mixed string, so yi is a terminal or a non-terminal. So we can say yi is, well, actually is in sigma, is it v? What symbol do we use for non-terminals? N? I can't remember.
Usually just capitals.
Huh? No, I mean for the set of non-terminals.
Oh.
Yeah, I thought so.
I don't remember that either.
Double bar T.
So there we go. We can write our way out of it. Yi is a terminal or a non-terminal. And then we looked at it and we said something along the lines of, if this guy y1 does not have epsilon in its first set, then whatever this stuff is will never impact the first set of the entire thing, because the terminal that determines, or the non-terminal here, this y1 that determines the first terminal in any string derived from it, will be this guy here. If there were an epsilon in there, then we could be in the situation where we lost this thing because it derived epsilon. Then we had to look at this guy. But if this guy doesn't have epsilon in, then it's just the first of this guy and this guy we need to look at. If this has epsilon in, then we need the first set of this one, actually the first set of this one minus epsilon, plus the first set of this one minus epsilon, plus the first set of whatever the next thing is, so y sub 3. And it's only if all of these have epsilons in their first set, we should have epsilon in the first set of the entire thing. Which, if you think about it, makes sense, right? Because what does it mean that epsilon is in the first set? Well, it means that the entire thing can disappear in a derivation. And only if all of these can disappear will the entire thing disappear, which means that all of them have to have epsilon in. So we can certainly say something like, I'm going to write it out. It's written in a little bit more compact notation in table 4.1. So we'll say the first of y1 minus epsilon is in the first of y1 ... yn. And then we can say if epsilon was in the first of y1, then the first of y2 minus epsilon is in the first of the entire thing. If epsilon was in the first of y2, then the first of y3 minus epsilon is in here, etc., etc., etc. only if epsilon is in the first of y sub I equals 1 dot of n, do we get epsilon in the first set of the whole thing. Okay. So should we give it a go? Let's do an example. Let's just do example 4.3. And we have a grammar that looks like this. So A goes to little a or BE. And incidentally, ABE spells monkey in Danish. Bet you didn't know that. What do monkeys say? Oh, I do a great monkey impression.
Well,
But not on video.
Oh. Sell out.
Yep. I can just see that ending up on YouTube. Oh, wait, I'm going to upload it myself.
You don't want to be internet sensation?
Hey, you could be an influencer.
If you can become an influencer from making animal sounds on YouTube and make a living off of it, does that beat this job?
Well, that's personal evaluation. If you feel it is, I suppose.
That's just
Right.
annoying.
So let's do a table over here. Let's do it here. If x is something, then what is the first of that x? So let's just do the well, I don't know yet, Daniel. I'll tell you at the end of the semester how it went, because this is going to be the first semester that we have had that is completely online. I feel that it's going much better than I sort of anticipated. I've had guests coming yesterday to office hours, to a point where I didn't even manage to shower or shave until everybody left. So it was a very ugly experience, but at least there was somebody there, so I wasn't just sitting around by myself. And I feel there's a good interaction in the class. So this video uploading stuff mostly works. You know, it could have been a lot worse. So all in all, I will call it a success so far. But I guess we'll find out later on. So let's see. We'll do the oops, not like that. We won't. We'll do the right hand sides: A, B, E, epsilon. I guess we don't need to redo that epsilon there. B and C, B and D. I mean, these are super simple, right? Because rule 1 applies to the first one, so that's just an A. Rule 2 applies to this one, so that's just that. And rule 1 applies to this one, so that's just that. Now let's do rule 3 on this one down here. So we know that it contains the first of C minus epsilon, which is just C. But since epsilon is not in the first of C, then that's got to be it, which makes sense, because what do any string generated from terminal C, non-terminal B, terminal D start with? Well, they start with a C. Now, now we need to figure out what to do up here. Well, we can sort of use the same thing. We can say that it definitely contains the first of B minus epsilon. Well, we need to figure out what the first of B is. Well, that's easy enough, because we've done all of those. So it's just B union C union epsilon, which is just B, C, epsilon. So the first of C minus epsilon, the first of B minus epsilon is B and C. And then we have to look at the next guy, if there was an epsilon in first of B, and there was, so we have to union that with the first of E, epsilon removed again, and that thing here, of course, is just an E, so we get B, C, E. So A, B, C, E, epsilon, B, C, and B, C for that one. I suppose if we really wanted to, we can also do the first of A. Well, that's just going to be A, B, C, E, and epsilon. Yeah, we got it right without even looking. So there we go. Yeah, but the next couple of phases get much more fun than this. The first two are a little bit tedious. Why is E included in the first of B? Well, because the rule says that I take the first set of the first guy minus epsilon, that's included. And then if epsilon is included in that first set, then you look at the next guy's first set minus epsilon. If epsilon is included in that, not in the... So it's not if epsilon is included in this thing, because it's not, because you take it out. It's if epsilon is included in this thing. So you just keep going your way to the right. So I look at this. I need the first of B. First of B is BC epsilon. So first of B minus epsilon is BC. But because epsilon is in first of B, look, it's right there. Now I need to look at the first of E minus epsilon. Well, there's no epsilon in there, so that's just E. So I had BC, and this was an E, so I get BCE. Yeah? Keine Hexerei, nur Behendigkeit. Right. So, let's do example 4.4 as well, because then we're cooking with gas. So example 4.4. And it looks something like this. B or C. Something, something, something. There's a rule for B that goes here. I don't know what it is, and it doesn't matter. There's a rule that goes like this. And let's assume that the first of B is AB. And the first of C is CF. And let's assume that W is some string A beta. So that's the string. Right, now remember, actually let's just say W here. W is in the language generated by A if and only if A in a number of steps can generate W, which happen to be equal to A beta. Is there a way you can get infinite loops in finding epsilons? Yes, there is. Well, not epsilons. But if you get to something that says that the first, we'll probably see some examples of that later. Actually, we definitely will. But when you get something where you get an equation that says first of A is first of something that you can calculate plus the first of A, well, then you can just ignore that second part of first of A, because of course the first of A is included in the first of A. So really what you're looking for in terms of a solution is a minimal fixed point to that equation, and the easiest way to do that is just ignore the part that repeats. Otherwise, you may end up in an infinite loop, and you won't get to the next example or the next question. Right. So what do I got? So if I look at this stuff here, I can see that if this string W, which is made up of an A and something else, which is also a string, but possibly more than just one terminal, if that indeed is a string in the language, then we should be able to parse it using the grammar. In other words, we should be able to derive it. So we can certainly also say here that this is the same as W is, well, actually it's not, it's equivalent, because that's, That is, W is derivable. And we're doing first sets with one look ahead, so we should be able to derive this with one look ahead. So here we go. Let's give it a go. We know that we should be able to do this in a number of steps without backtracking and without making mistakes. So can I determine if my input is A and some other stuff which I can't see because I only look one ahead, but it's a beta thing, and I'm just going to put this thing here is just an enter file. And I'm just putting it there now because I know in the future I'm going to write it and we're going to need it, and then I'm going to forget to tell you what it is. So now I've told you that that dollar at the end is enter file. Right, so I have two options, right? I can go this way and do a B, or I can go this way and do a C. And I want that B to be a green B. And I have to make a choice, and I have to make the correct choice. Now, which one is the right way to go? Should I go A goes to B or A goes to C? Anybody? B. Why B? Well, because of because of the little a, right? So, what I'm doing is what you're doing is you're looking at this stuff here, right? So you're saying, all right, this statement here that says the first of B contains little a and B. That means any derivation. Any derivation of a string starting with B must start with an A or a little b. Any string derived from C must start with a C and an F. And if I'm trying to parse a string that starts with an A, then taking a C here will surely give me something that starts with a C and an F, and that doesn't start with an A, so we better take that one, right? So I know that B is the correct one. So this one is the correct one because A is in the first of B, and the next input, I always tend to call them characters because we use characters, but really they are tokens or terminals. Is also A. Right? Okay. Fine. Let's try something else. A goes to B and C, and first of B is, who knows? First of C is, who knows? So can we now derive a relationship between the first of B and the first of C such that with one look ahead we always make the correct choice, at least for A, right? There were other things in the grammar, then who knows. So if I'm just looking at as a snippet like this, then what must be true between first B and first C in order for me to always be able to choose either B or C when I'm doing a derivation in which I'm replacing an A by something? Anybody? Well, so what happens if first of B is equal to first of C? So let's explore. If first of B is equal to first of C, and let's say that it's equal to something that has an A in it. Then consider this an input with an A and something in the file, and a derivation in which I have an A, which I now have to replace. Should that A be replaced by the B or by the A? Well, I don't know, right? Because if it's an A and it's in the first of B and it's in the first of C, then that's not good. So this tells me if first, oops, that should have been a B, shouldn't it? If first of B and first of C share any elements, then for these we cannot always pick the correct next step. All right, then somebody said that their first sets are different. All right. So first of B, how do I say that? Well, actually I can do this, has nothing in common with first of C. Right? So if they have nothing in common, then I'm never in a situation where I see something on the input and I don't know if it came from first of B, first of C, or neither. Or it certainly could be that it was neither, right? In which case we would just get an error because there's no way to create that that derivation. And we want to do this with just one look ahead for now, at least. One look ahead is the nicest to work with. So this is a necessary condition. We'll see later on that when we start mixing some epsilons into things, then this is not enough. But it is almost enough to determine if we can parse the language with one look ahead, left to right derivation, i.e. if the language is LL1. As I said, it's not a surefire conclusion that if this is the case, that these first sets intersect empty, that you have an LL1 grammar. But if you were given a grammar and you were about to be pushed off a cliff in 5 seconds and you could only calculate first set and not predict sets, then I would take my chances on that, unless of course it was somebody really devious like Larmor that came up with some complicated grammar. Then you might end up falling off. But you know, what can you do? Right. I want to take this further. I mean, not pushing anybody off a cliff yet. Yeah. This is the this is going to be the trash cannibal offense, and I have taught compilers since 2003, most semesters twice. We have never managed, in the span of 17 years and a good 26, 27 installments of this telenovela, to get this right all the time. There's always at least one person who insists on ruining it for everybody else. So let's hope that everybody gets it right this year. Let's try this then. What is a necessary condition with respect to first sets for this to be LL1? So for this to be LL1, Ben said you want to make sure that the first of B and the first of C has nothing in common. Okay. Can we translate that to this? And we have to be really, really careful, right? Because when does this go wrong? So can you give me some so if I say over here, example, first sets that break the LL1ness. So first of B, first of C, first of D. So can you give me some terminals to put in here, and I'll take a minimal example, so I don't have to write very much, that would make this grammar not LL1. Anybody have an idea? Now what if I put AB? Okay, let me write this down. AB. I suppose when I ask a question, I have to give a little bit of extra time for people to write things. Why is this bad? Well, it's bad because these guys have an A in common, and these guys have a B in common. And you know what? I'm so glad that you didn't make an example in which all three of them had an A in common. Of course, that would be a problem, and that would break everything as well. But this illustrates the point much, much better, because this goes bad if just two of them have anything in common, right? Actually, it doesn't matter what the first of D is, because we've already broken it with the first of B and the first of C. But the reason I like your example here a lot is because it illustrates perfectly the solution to the question of what is a necessary condition for the first sets in a situation with three right-hand sides of the same left-hand side to be LL1. And obviously, this breaks it. So if B and C have anything in common, that's a problem. If B and D have anything in common, that's a problem. You could have made this example only better if you had done the following. And then done it in blue, of course. Because what do we have now? We have these two here, and these two here, right? So if any two of these first sets have anything in common, then things break. So if any two sets have anything in common, then it's not LL1. Because if I were trying to replace an A by one of the things that is shared between at least two first sets, then I wouldn't know which one to pick, and then I wouldn't be able to make a good decision on what the next step is. Because remember, when I move forward, I can only move forward along the correct path. So no backseas, right? If you take a step, it's got to be the right one. So that the trash cannibal offense that people make, they say, okay, what is the necessary condition for this? And I'm not even going to write it down. I'm just going to say it, knowing that you'll probably have forgotten by tomorrow anyways. What happens if I said the first set of this intersected with the first set of this intersected with the first set of that? Why is that wrong? Well, what happens if I intersect this guy with this guy and this and this one? What does AB have in common with AC? Well, it has A in common. What does A have in common with BC? Nothing. So we got the empty set, so everybody's happy. No, because it goes bad here, it goes bad here, and it goes bad here. So the correct spiel here is that the first of B intersected with the first of C must be empty. The first of B intersected with the first of D must be empty. The first of C intersected with the first of D must be empty. So that is all pairs of first sets must intersect empty. Right? So let's just do the general case. So if I have A goes to x1, x2, dot, dot, dot. Actually, let's call that A1. xn. Actually, no. Let's redo that. Get some proper. No, this was fine. Oh, crud. So A1 goes to, actually, this is the important observation in the book, so we'll call it alpha 1, 1, alpha 1, 2, dot, 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 alpha 1, n1, dot, 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 a m, alpha m1, alpha m2, dot, 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 alpha m, and m. So that is a very, very general context-free grammar. It has m left-hand sides and a number of right-hand sides determined by n sub whatever. So we can now say here that A, actually, before we do that, can I do this? And then can I take this guy here and move here and then go here and then forget what I just said. So let's consider the following instead. Because this is also some nonsense that people sometimes say. A goes to B or C. B goes to little a or X. C goes to D or Y. Q. Q goes to A or X. And then I ask, is this grammar LL1? So in other words, can I always predict what the next step in the derivation of the input is if the input is derivable? It looks like it. Yep. Is there anybody who will say no? Probably nobody's going to be to say no, right? Lowercase are terminals, so B and Q don't matter. Lowercase are terminals, so B and Q don't matter. Well, I don't know if that's true, because if I look at the first set of this guy, what's the first set of that? That's a X, and the first set of C is dy, and they have nothing in common. The first set of this guy is an A, the first set of this one is an X, they have nothing in common. So, good, good. This first set is a D, this first set is a Y, they have nothing in common. So, check. And this is an A, this is an X, they have nothing in common. So, check. Yes, probably. We can't be sure, but it looks pretty good. So you say B and Q are not shown to be on the same right-hand side of a production, right? So if B and Q were on the same, then we would definitely have a problem, right? Because then that would be an issue. But here's the mistake that people make. They say, right, this grammar is not LL1 because the first set of this and the first set of that have A in common, so therefore not LL1. And that is wrong in so many different ways, because think about what we're trying to do. The reason we're looking at this is because we're always trying to figure out what is the next step in a derivation. And the way you take the next step in a derivation is to say, right, once I know what my, let's say we're doing a leftmost derivation, once I know what the leftmost non-terminal in my sentential form is, then I've already decided what it is that I'm going to replace. So if the sentential form that I'm looking at has a leftmost terminal that is a B, then I know that that replacement is going to be with either an A or an X, or it's going to be an error if the input is not in the first set of this guy or that guy. So I'm never in a situation where I have to pick one of these right-hand sides at the same time as I have to pick one of these right-hand sides. So basically, what we can get out of this is that we only consider intersecting pairs of right-hand sides that have the same left-hand side, because we've decided which left-hand side we're replacing. We know what non-terminal we're replacing in the derivation, so we got to pick the correct right-hand side. So therefore, we do these pairwise intersections of right-hand sides. All right. So that means if I want to write this, I stopped in the middle of a word. So a necessary condition for this grammar, I don't know why I needed a capital G on that. For this grammar should be LL1, right? So what we know is that if I look at these guys pairwise, then these two can't have anything in common. These two can't have anything in common. Those two, those two, those two. But that's all within this particular rule. But the same goes for this guy here, right? These two can't have anything in common. These two, those two, and those two, and so on and so forth. So what we can do is we can say, for all I, where I is between 1 and M, so this says pick a left-hand side. Once I pick the right-hand side, now I'm going to pick two. Sorry, once I pick the left-hand side, I'm now going to pick two different right-hand sides. So I'm going to say for all j and k between 1 and ni because I fixed the I here, so now I just want that maximum. So for all of that, where that's the case, and of course, let me also just make sure that j and k are not the same, because I don't want to pick the same two. So this says pick two different right-hand sides of that left-hand side. And now we're in business because we know all we have to do is we have to say that the first set of alpha I j intersected with the first set of alpha I k must be empty. Ta-da! Right. Good for us. Now, it's always nice with a little upside down math. We'll do next time. I'll just do example 4.5. I don't have time to do it today because we only got 2 minutes left. But do me a favor. Actually, next time we need to talk about the next phase, right? So you need to cancel all your weekend plans, which is fine anyways, because chapter 6 is from page 316 to page 350, so 30 some odd pages. And most of it really is just telling you stuff that you already know. And then next time I'll tell you how to implement stuff that you already know. And this is all about, you're not a free man at all. Not only do you owe me a type checker, you owe me a type checker that can, you owe me a program that can generate type checkers. So, you're just signing your life away. Right?
Tacos as well.
Well, yeah, he owes me. I told him he could bring me tacos, but he just flat out refused. So this phase 2 is name resolution, which means that we're checking that names are defined before they are used. So we need to talk a little bit about static scoping and dynamic scoping and how we can check that static scoping rules. What do you mean you're driving across the country this weekend? You don't have time for that sort of nonsense. Can't you fly like real people? Yeah, fly. It's easier.
Oh, yes, go build a plane and fly the plane and.
Not with a dog and a baby. Why? You can put both of them in that little box and just check them in. I think no, it is not cheap to fly right now. I paid a fortune to fly to Europe over the summer. Right, so that's it. I'm going to stop recording and get ready for the next lecture. So I will see you on. So sorry, there's a subtlety I may not be understanding from earlier. Would first of epsilon b be a b instead of an epsilon? Because if there are any, you know what? Ask me that question next week because everybody's leaving now. So keep that one on the burner for next time and ask me again. So write it on a post-it and we'll look at it next time. Okay? Ta-ta for now.